Here we're going to be looking at constructing a very specific thing, which is the vector equation of a line segment. And you can see the formula here. We've got r of t being equal to 1 minus t times r0 plus t times vector r1. Particularly, this is going to happen from time 0 to time 1, and it's going to join essentially the vector that represents the point r0 to the vector r1. So we want to create a line segment from one point to the other, but the way that this does this, again, is a very specific construct. It does it from time 0 to time 1. So at 0, we're at the initial point, and at t equals 1, regardless of how far away it is, we're at that terminal point. And that's probably the easiest way to think about what these two things are representing here. This is essentially your initial point, and this is your terminal. We just use the vector notation there to represent the vector that points at that specific point. So we've got an example here that we can work through. I've asked to find the vector equation of a line segment that's going to join the point P to a point Q. And it really is just a matter of plugging it into this particular formula. So we start out with our vector equation, r of t, being equal to the vector that points to the point P. This is our initial point here. And that vector is going to be the same coordinates, 1, 3, negative 2. And we're going to multiply that times 1 minus t, again noting this first construct here, plus t times the point q, or the vector that points at q rather, which would be 2, negative 1, 3. And I don't know why I put these in a reverse order, but I did. So there you have the general construct. That's not usually how we leave it, though. We actually are going to simplify this out, and that means that we'll distribute this through. So I'm going to have that r of t is going to be equal to 1 minus t, 3 minus 3t, and negative 2 plus 2t. And here we'll do the same, and we'll get another vector here. Let's clean that up a little bit better. 2t, negative t, and 3t. And now it's just a matter of adding these two together to get our vector equation here. So finally we end up with 1 plus t, 3 minus 4t, and negative 2 plus 5t. And there you have the line segment that connects P to Q. And just to verify that it does what we want it to do, again, the idea is that t equals 0, I should be at the initial point, and at t equals 1, I should be at the terminal point. So if we plug in t equals 0, you can see we are, in fact, at 1, 3, negative 2, like we should be. And if I plug in t equals 1, I'm at 2, negative 1, and 3, which is, in fact, the coordinates for our Q.